Hello guys, welcome back to Kolbenkraft. We have already talked about rolling resistance and we have seen how the concept is and what does it mean. But now it's not quite clear why energy loss takes place through rolling resistance now, and what causes the energy loss. So we know that the rubber has this property viscoelasticity, because of which rolling resistance takes place. So now what exactly does this term mean? Let us take an example here. Suppose there is this material, viscoelastic material. When we exert a force on this material, it will deform a bit, and after a few moments it will come back to its original form. So this thing is quite simple, that it is quite understandable that it takes a few minutes or few seconds, some amount of time, to come back to its original form. During this period, it loses some of its energy, and this time that it takes back, this phenomena is called as hysteresis. So now, as we know, some energy is lost over here. This is the same fundamental which can be related to the rolling resistance in an automobile, in the wheel of an automobile. So now, okay, there might be a confusion over here to, like, how does the energy gets lost just in getting back to its original form. So let us take a system which is the spring damper system. We know that the material of a rubber is very much similar to a spring damper system. So now, when we exert force over here, we can literally imagine this, that when we exert force on a damper, if we do it like slowly, the pushing and the pulling action, very the frictional force that is felt is not that high, it's not that great. But if we increase the frequency, then the frictional force that we feel is quite high. In the same way, there is this thing acts as a this system, the spring damper system. So now, when it when the form that when the change in the form takes place, the frictional we can say that the frictional force, yeah, for understanding sake, we can say that the frictional force that is acting, because of that the energy loss takes place. And so, taking this on the practical application, considering a tire rolling on a surface, this contact patch this contact patch is we can imagine many spring damper systems in this contact patch. So now, as the wheel rolls, as the wheel rolls, there this system this for the sake of understanding, we'll say here that these systems of spring and damper get compressed and expanded at a quite high frequency. The frequency here can be from 10 raised to 6 till 10 raised to 9 hertz. So now, as the frequency is high, there will be more, we can say, a frictional force, or in other terms, there will be more rolling resistance. So behind all these things, there is only one property, that's viscoelasticity. So because of just this viscoelasticity is the rolling resistance taking place, and hence more fuel consumption also takes place because of this. So and yeah, one more thing is, we cannot say if there are all the tires are made up of rubber, but we cannot say that the rolling resistance in all the tires are same. Rolling resistance very much depends on, like I said, viscoelasticity. So how hard the tire material is, or how soft it is, that decides the level of rolling resistance. Thank you for watching this video, and if you have any queries, the comment section is all open to you. You can just mention it down there. Thank you.